depth, and below that depth they do not reach out. So they do not get washed away and then they accumulate under the surface soil. So that is a challenge of farmers, even in Verde Valley. That is one of the biggest challenge because roots cannot penetrate well enough in that soil, in that layer, and then they have there is bad drainage, water drainage. And also because these are the salts of calcium carbonate, they cause even greater pH, I mean they cause rising pH of the soils. So desert farmers, they focus on improvement in soil health to improve the water retention because arid lands, they do not have much availability of water. So desert farmers should focus on increasing soil health, and the key to soil health is addition of organic matter. So that's the picture shows, so a little bit you can see here the white table salt minerals accumulate because there is not enough rainfall to wash soils out of the soil profile. So this is one of the research projects I'm involved in. It is a NIFA project, and the farm here is Agritopia. It's an urban farm in Gilbert, and this is one of the prettiest farms I've ever seen in my life. It's so pretty. They are growing fruits, vegetables, nuts. It's a 11-acre farm, and it's a certified organic farm. And on a small area, we are doing our research trials with grape pomace. And I would discuss a little bit about grape pomace as we go further in the presentation. And the objective is to assess the soil and plant health responses to composted and solarized grape pomace with manure in semi-arid croplands. Solarized grape pomace is just dried grape pomace, and other we are using is composted grape pomace with manure. And I will talk about why we chose this amendment and why we are mixing manure. So before I talk about my experimental layout or how we have set up the experiment, I would like to talk a little bit about grape pomace. So what is grape pomace? So grape pomace is a byproduct of wineries. It is the material that we get after the grape juice is extracted. So it is composed of grape skin, grape seeds, stalks, after the pressing occurs, and the material we are left with. It is rich in nutrients, it is very high in organic matter, and it is acidic material. So it could be a potential soil amendment for arid lands or arid areas where the soils are alkaline and the soils are low in organic matter. So this could be a potential. So that's why we have chosen this amendment as one of our treatments. And we want to see the effect of both composted and just dried grape pomace. And we want to compare because earlier people have been using composted grape pomace, but not many people have researched with, or in practicality they are not using just dry grape pomace. So if we get good results without composting, we would not want to spend our time, effort and cost on composting the material. So that was the objective behind using both grape pomace. And then when we also mixed it with manure, so mixing it with manure is also one of the treatments in the plots, because manures are generally alkaline, and because grape pomace is so acidic. I will show you the acidic composition. We have the chemical composition of sun-dried grape pomace, and you can see the pH, it's 3.9, so it is very, very acidic. Mixing it with manure can help lower the pH of the manure, because manure is very alkaline, so it can help lower the pH of manure. The way I have set out my experiment is that I have 3 replications. So so one replication can be treated as one block. Then we have second replication, that means second block, and then we have third replication. So for each treatment, we have 3 replications, and within a block, within a replication, the treatments have been randomized. The treatments have been randomized, and this kind of experimental layout is called randomized complete block experiment, so that we cover all the variabilities. And we have 11 treatments. So first one is no fertilization. That would be our control, where we are not applying anything at all. No fertilizer, no grade maize, no manure, nothing. And then second one is composted grade, just composted grade for maize. Then the third treatment is composted poultry manure. Then fourth is composted horse manure. Fifth is the combination of grade for maize and poultry manure. And then again, grade for maize and horse manure. And then we have just dry grade for maize, dry poultry manure, dry horse manure, and then mixture of dried manures and with grade for maize. So this entire farm is 11 acres, and that's just our research field where we have set out our plots. When we applied the amendments, so that's how it was looking when we just applied the amendments, and then they were, after applying, they were like into the soil, they were mixed into the soil manually. And then this is the result I have after 50 or 52 days after planting. So I have baby spinach growing on it, and baby spinach would be the spring crop, and then we would be growing cowpeas in the summer. And the effects would be seen on both, like we would determine or analyze the effects on both plants. And then soil samples would be taken just once a year in fall, around September. So I'm still to determine the yields, but we could see here that so this was no fertilization, this plot here, and this plot here had P5 treatment. So we can see, I mean visually we can see difference in these plots. And P5 treatment is, if we go back, it's the composted grade for maize and poultry manure. So that combination is working good. So now, we still have to test the soil samples. I can just visualize and see that I am seeing certain differences, but only after we get the soil tested, we would really come to know what's happening in the soil. And that's affecting the uptake of nutrients by the plants, which is further affecting the yields. So that would give us more information on it. So the soil parameters that I would be looking into are the physical, chemical, and biological parameters. So for physical parameters, I am looking into aggregate stability of aggregates. Do they crumble easily, or how stable are the aggregates, soil aggregates? Water holding capacity, that's one of the key indicators of soil health. Is my soil able to hold water easily or properly so that the water is available to plants for uptake? And then for chemical parameters, I would obviously be looking at nutrients and organic matter levels and soil acidity, soil pH, because pH is key indicator of soil health. It is going to determine the microbial activity in the soil, microbial population in the soil, availability of nutrients in the soil. For biological parameters, I'm looking into microbial diversity and soil respiration. So generally, in a healthy soil, you would see more diversity of microorganisms. and then soil respiration. For plant parameters, I would be analyzing the tissue nutrient content. So I would take plant samples and get them analyzed for nutrient content in the above ground biomass, and then plant biomass production, and then phytosphere microbiome. Phytosphere microbiome is the microbiome inside the plant tissues, because I want to see if applying these amendments is conferring any resistance to my plant for virus infections or disease resistance. So the expected outcomes are that application of these amendments would result in better soil physical characteristics, greater nutrient content in the soil, better yields or biomass production, greater uptake of nutrients due to nutrient uptake efficiency, and greater soil microbial diversity. But we should always remember that when we are dealing with organic amendments, we do not expect to get the results like instantaneously, because organic amendments or organic materials take time to show their effect, because organic material has to be broken down by microorganisms, and microbial activity would depend upon how the climatic factors are, and various things go into because when we apply fertilizers, the nutrients are instantly available to plants, because that's the chemical composition. It is not going to add any organic material to the soil. So nutrients derived from organic fertilizers are not readily available to plants. So I may not see great yield differences in my first year, but these are long-term projects. So these are like 3 to 4 year projects. Because we are dealing with organic amendments, that's why the timeline has been decided. Had we been applying urea, just once the growing season would have been enough for my project. But because we are dealing with organic amendments, we have to be very patient. They may not show results in terms of yields, they may not show results in first year, but definitely down the lane, as the soil improves, we are going to get results. That's why the farmers who are transitioning into organic agriculture, they take like 3 to 5 years, and the first years it's very disheartening because you don't get any yields at all, because the soil is so used to getting nutrients from urea and other fertilizers, synthetic fertilizers, that it takes time to come to its normal self and then replenish itself. So this is just the Edutopia project is one that is based out in Gilbert, and other projects are all based out here in Verde Valley. And so Verde Valley, it has, as compared to other regions in Arizona, like in the south, Verde Valley is known for its good weather, good climate, and there is comparatively more water availability here, and its soils are also better as compared to other regions in Arizona. So that's why we have farmers out here. We have things growing here. So my projects are based in 4 locations. We have Clarkdale, we have Walden, and then I'll show you as I go further in this slide. So one experiment that Isaac did here using the soil with great pomace, and he really did see a lot of beneficial effects of using great pomace, because we have wineries out here, and they generate great pomace, and disposing great pomace can be very problematic when it comes to it has environmental issues, it has economic issues. It's really challenge. It is a challenge disposing that great pomace. So if we can utilize that material, and like if wineries are producing it, and they can use it and then they can use in the farm itself, they can apply it to their own soils. That would eliminate the problem of disposing the great pomace, and that would you don't have to, look into other sources of nutrients for your vineyards. So you have material that you are generating, and then you can use it on the farm. Then you can use it in the farm itself. So the objective was to see the effect of grape maize addition in addition to farmers' practice, enhances maize, wheat, and grapes performance in semi-arid soils. So, to determine the effect of grape maize addition on maize and wheat, he did a greenhouse study. And to determine its effect on grapes growth, he did an experiment in field. And the field was located in Javelina Wheat Vineyard in Cornwall. And the greenhouse was in Verde Valley Senior Center in Cottonwood, and the soil was obtained from University of Arizona DK experiment station. So he conducted two experiments. One was in greenhouse, other was in field. The field was vineyard, and the greenhouse he obtained the soil from this DK experimentation station, and then he grew wheat and maize. So for the greenhouse, there were two treatments. 95%, one was the standard farmers practice, and the farmers were using poultry manure in that soil. And the other treatment was farmers practice and in addition to farmers practice, he was applying grape maize. So that was the second treatment. In the field, it was again the farmers' practice, that was yearly fertigation. They were fertilizing their vineyards, and then addition of grape maize in addition to the farmers' practice. So parameters that were assessed were crop performance. So they looked into the yield data, they looked into the plant tissue nutrient concentration, and soil fertility. They checked nutrient contents in the soil, pH of the soil, and then microbial diversity and microbial biomass. So the overall results were, in greenhouse, adding 5% grape maize to soil significantly increased maize and wheat growth and shoot elemental concentration. That means the plants were taking up more nutrients, and the more nutrients were available in the soil for plant uptake. And in the field, again, addition of grape maize significantly increased growth or nutrient concentration in the leaves and yield by 48%. So both in greenhouse and field studies, significant results or improvements were observed in terms of yields and plant tissue nutrient concentration. So how was it happening actually? So application of grape maize. So grape maize is rich in phenolics, organic acids, and organic matter. So what it is doing is it is providing food for the microbes. So that is increasing the microbial biomass. And also because grape maize is acidic in nature, it is reducing the soil pH. Because the soils were alkaline, they were from Verde Valley region, and the Verde Valley region has alkaline soils, it was reducing the soil pH. So due to reduction in soil pH, more nutrients were becoming available, because as soil pH increases, there is an optimal range where the plant nutrients are available to the nutrients in the soil are available to plants for uptake. If it goes above or below the range, the nutrients become unavailable. So if at high pH, iron, for example, when pH goes above 8.5, I would say the iron in the soil becomes unavailable to plants. So as addition of grape maize was reducing the pH in the soil, more nutrients were becoming available for plant uptake. And increased microbial, because organic matter was being added, there was more microbial diversity seen, there was more microbial biomass seen. So that increase led to the increase in microbial biomass and diversity and decrease in soil pH, which made more nutrients available to plant uptake, which increased the above ground plant biomass and increased the yields. So the initial soil pH we can see in the field and in the greenhouse, the soil that were used in the greenhouse, they all had, both the soils had pH 8.1 and 8.1, and the grey pomace has 3.9 pH. And addition of grey pomace really helped in amending the pH of the soil. So if we see just to see the effect of grey pomace on pH, they did, so the treatments here are 5% grey pomace, and then there was just 95% soil. And then this was, so these treatments were just to analyze the pH, because pH is one of the main factors that we are concerned about because of high alkalinity in these regions. And pH is the main indicator of soil health, because it is going to determine the microbial parameters in the soil, the nutrient availability in the soil. So Isaac took several, he did several treatments he increased the content of grey pomace just to see how it would affect pH, and we can see that linearly, it's decreasing. So as we increase the percentage of the grey pomace from 5% and then 10% to 20% to 40%, we can see how there is decrease in pH in the soil. And this is the result from the organic matter level and nutrients in vineyard soils. This was a field experiment, and how organic matter and nutrients were affected due to the addition of grey pomace in the field soil. So if we see here, this is the organic matter, and this is just the farmer's practice, the standard practice that farmers was practicing. And then addition of grey pomace with the farmer's practice, you can see that there is a great, there is an exponential increase in organic matter. It has significantly increased, and then there is also increase in nitrate content in the soil, nitrogen content in the soil, phosphorus, and potassium, but it did not really affect copper and manganese, and there was increase in iron as well, and zinc. So addition of grey pomace did affect nutrient levels in the soil and significantly affected organic matter. Then comes the result of the shoot biomass and elemental concentration in the greenhouse study. So for the greenhouse study, he had two plants, wheat and maize, and then he did see a high biomass, above ground biomass, with the addition of grey pomace. High above ground biomass and nitrogen content in the plant shoot, phosphorus content in the plant shoot, and potassium content in the plant shoot, manganese content in the plant shoot. So they all increased significantly. But there was no effect on the zinc, but there was also increase in the iron and copper content in the plant shoot. That means more nutrients are becoming available for plant uptake. And more nutrient availability is resulting in higher yields. Similarly, for the wheat biomass, also for the wheat biomass, it did not see any significant difference in the biomass weight, but it did increase the nitrogen, phosphorus, and potassium content in the, and zinc and iron content in the plant shoots. And then is the grape yield and leaf elemental concentration. So how did the addition of grey pomace affected the grape yields? So we can see number of fruits, clusters per plant, they were significantly higher in the treatment where it had grey pomace. And then fruit weights was higher with grey pomace addition, and fruit weight per hectare was higher but it did not affect sugar content in the grapes. In the elemental concentration in grape leaves, it had higher nitrogen, higher potassium, higher manganese. These were the three nutrients that were affected. So if we see the microbial diversity in the greenhouse experiment and in the vineyard soils, you can see that with the grape or maize addition, we see high proportion of microbial diversity as compared to the standard farm practice. And similarly here in vineyard soil, we see slightly greater proportion of microbial diversity. And if we individually see, so we have bacteria, actinomycetes. So if we see here, so we can see that saprophytic fungi, so this green area here is saprophytic. The higher microbial diversity is being contributed by greater saprophytic fungi. So that means grape maize addition is increasing the diversity or increasing the proportion of saprophytic fungi in the soil. And here also if we see actinomycetes and gram-negative bacteria is higher, that's contributing to the greater biodiversity. So in terms of microbial biomass, so again we can see this is the standard farm practice and this is the addition of grape maize. We have higher higher microbial biomass in the soils which have grape maize added to it. Similarly for vineyard soils, we can see we have higher biomass, and this is being contributed by the total fungi. So the total fungi, if you see here, gray here and gray bar here. So that's because of the fungal population has increased in the soil with grape maize. So he correlated, he statistically analyzed and correlated soil pH, microbial biomass and diversity to whether we should elemental concentrations, and he found that because the pH is significantly related to biomass. So that means biomass, as the pH is decreasing, biomass is increasing. There was significant correlation between these two factors. So that means decrease in pH was favoring the microbial, they were allowing more microbes to grow because higher alkaline pH is, or even very low acidic pH is harmful to microbes. So if we talk about plants or microbes, there is an optimal pH range at which they grow and function. So less or above or below that range is going to hamper their activities, their production. So that is all about the study that Isaac conducted with grape maize, and that really grew our interest in using grape maize as an amendment for the research that we are planning to conduct in Verde. So we have ventral farms in Clarkdale, and so that is going to be one of our research sites too. And so we are going to we would have 4 treatments here. So we would have cover crops, we would have control where we won't be using any kind of manure, and then we would have manure and cover crop, and then we would only have manure. So we are still deciding on whether we would be using horse manure, because that would be dependent on the soil analysis. We took the baseline soil analysis, we took the baseline soil sample, and now we are going to send it out for analysis. So our selection of, or our choice of the amendment would depend upon the soil characteristics or